name is Jim Jensen. My mentor is Dr. Pamela from Grand Rapids Community College. And the project that I'm working on this summer is the ordination and classification of the hardwood forest here at Pierce River Creek. And I like to look at ordination as a definition of the study of variables and how those variables correlate with each other. So the two variables that I'm studying are species composition data and environmental parameters. And within the species composition data, I'll be classifying the 6 separate stratas within the plant communities there.
You can just use the mouse, and I think the mouse is already there, but yeah, we're good.
All right, so what I've done so far this summer is I've set up 30 sample plots in the hardwood forest, and these plots are 20 by 50 meters wide. And to make sure that they're somewhat random, when I first get out to the hardwood forest, I roll a dice once and then walk so many paces south, and then roll a dice again and walk that many paces to the west. So that gives me my northwest corner. And from there, I started with my northwest corner with every plot. From there, I stretch my tape 20 meters south, mark that corner, and then stretch my tape 50 meters east. And I'm using a compass as I'm walking along with a tape measure. I'm using a compass to make sure I'm walking due east or due south. And sometimes it can be difficult with the terrain, because the terrain wants you to go a little bit more south or a little bit north. So you're constantly checking and watching back and seeing that your tape is straight. And once I get all 4 corners set up, then I stretch from the southeast corner to the northeast corner and make sure that's 50 meters, because if it's 50 meters, then the whole plot is true and square. So those are some of the problems that I've had with that, but it hasn't been too bad. I'm using, and I also had 300, I kept track of all the pieces of flagging tape I used, because I didn't want to, at the end of the summer, guessing how many pieces of flagging tape are out in the field, so I'm using 10 per site, or 10 per plot. And in those plots, I've started gathering species composition data, and that's from the overstory and understory data collection. And when I first get into a plot, I visually set up the boundaries of the plot, so that way I know which trees are in and which trees are out, and I'm collecting the rate data. And I'm measuring, for the overstory and understory, it's all trees that are greater than 2.5 centimeters DBH. And so I measure all the trees in the plot, and at first I was using, to keep track of which trees I was measuring, I was doing it visually. And it became too much with stopping and IDing trees, using the deck was key, so I started using chalk, and that seemed to work good. For some reason, green, pink, and yellow works the best, so if you guys see me covered in pink chalk, that's probably why. Some problems that I have with tree identification, just an instance, is red oak and black oak. As you can tell, black oak from red oak, with the underside of the leaf, there is hairs on the bottom of the leaves. But with the trees up here, they're so big that you can't really get the leaves off the top of the trees. So one way that there's a couple of ways that I've gone about doing it between red oak and black oak. Red oak has raised flat ridges, and so that's one way that's somewhat distinguishable, but when the trees are young, they can vary and they almost look identical. So another way that I also use is by the fruit. So a lot of times I can find last year's fruit at the bottom base of the tree, and the black oak has an acorn cap that covers about half of the acorn, and the red oak covers about a quarter of the acorn. So that's a couple of ways that I use to identify red oak to black oak. And so what's next with species data collection? I have to cover the next 4 stratas, and in those stratas I'll be looking at the saplings, and I'll be tallying those each in the 20 by 50 meters plots. The shrubs and the vines I'll be visually estimating for percent cover in 10 1-meter squared plots. The tree seedlings will also be tallied, but those will be in 4 25-meter square subplots. And the herbaceous plants I'll be visually estimating those for percent cover in the 10 1-meter square plots. Next, the other variable that I'm looking at, like I said, is environmental parameters. And so far with that, I've taken soil samples in all 30 plots. And like it says there, I'm taking the top 10 centimeters, and I took 5 samples per plot, and that's 4 in each corner and 1 in the middle. And then I'm mixing those in one bag. And I found it difficult to mix those just in the bag, because I wanted to make sure that nutrients were properly dispersed all the way through the samples, so that I was getting the proper analysis of the soil. So I used a 4mm soil sifter, and that seemed to work pretty good. That looked pretty, I guess that's homogeneous, right? Mm-hmm. They looked pretty well mixed, and I also got advice from Sarah and my mentor Pam too, so that's why I went that route. can just see a couple of pictures of me sifting the soil, and then between each soil sample there, I was washing out the sifter to make sure that nutrients weren't being dispersed between each plot, and I was getting proper analysis that way. So what's next with environmental parameters? No, I still have to, going back to the soil samples also there, I separated all the soil samples into two separate bags, and I took half of the samples to Michigan State, and that was on Monday, so we're currently waiting on nutrient analysis now for that. And the other soil samples I kept in the lab. With the samples that I kept in the lab, I'll be running a Voight-Cruz hydrometer method, and that'll give me texture and size of the particles, and that'll give me like a composition of the soil, what percent sand, silt, or clay the soil is. I'll also be doing a slope and aspect, and I'll be using slope and aspect of all 30 plots. I'll be using an inclometer for that. And one last thing I'll be doing is pH and percent moisture in all 30 plots, and I have a Kilway soil tester that I'll be using for that. So data entry and analysis. With the data that I've collected so far, that is the overstory and understory data, I've got that all entered into the computer. It was roughly like 1,900 trees. And I've calculated importance values for all those species per the plots. And I've got 23 out of the 30 plots done for the overstory and understory data. And like I said, I've calculated importance values for those, and that's based off relative density and relative dominance. You add those two together and it gives you an importance value for the species of tree. Here you can see I have a graph. This is from plot 1, series 1, and here this is just the overstory. You can see at the bottom there that's a Quercus valentina, QUVE, that's black oak, and that has the highest importance value. And then on the lower end you can see Carya ovata, which is a shagbark hickory. That has the lowest importance value. And I'm using a four-letter coding system for the trees, and that's based off genus and species specific epithet. So that's for 2 letters of each for a coding system for it. What's next with data analysis? So once I have all my final data entered and manipulated with importance values and all the environmental data also in, I'll be using a software called PCORD6, and that's a coordination software. And what it does is it builds 2 matrices, one matrix for species composition data and the other for environmental parameters. And it takes both those matrices and overlays the two, and it creates a correlation between the two based on importance values for the species composition data. So allowing that importance value to tell me which environmental parameters are most important and based on function of the forest and why it does what it does, why trees are here, why plants are there, why plants are together, why they're not. I'll be learning a lot more about this PCORD6 as I go along. I haven't started using it too much. I've played around with a little bit of sample data and entered some of the data, so I do know how to, once I get importance values, I do know how to manipulate the data into the software, but I'll still be learning more as I go along. And future application. So why is this research useful? My hope is that this research project will be useful to Piercer Creek as a management tool. Say in 5 years they do the same research that I'm doing now. They can take a look at what short-term successional patterns are taking place and how the forest is changing and how to better management. And I think it would also be useful to look at the emerald ash borer with all the trees that are being eliminated right now and what changes the forest will take place with the elimination of those trees. So I'd like to say that I've enjoyed this research so much this summer, and I've enjoyed hanging out with all my fellow researchers, and I think that's been a big pleasure too. We have a really good group of people at the house, and I enjoy our evening conversations and fires and that kind of stuff. So, any questions?